Hello everyone. Welcome back to our AWS Certified Solution Architect Associate Certification Bootcamp series. Thank you so much for joining me today. In our previous sessions, we explored Amazon RDS in depth. Now we are going to dive deep into Amazon Aurora, AWS's flagship relational database service that combines the reliability of a commercial database with the simplicity of open source engines. Let's start with the session outline. We'll start with an overview of Amazon Aurora and then Aurora's most important features one by one. These are highly testable in the exam and equally valuable in real-world solutions. Then we'll review Amazon Aurora Database Cluster Architecture, followed by Amazon Aurora Read Replica feature and how Aurora supports Replica Auto Scaling if your application suddenly gets more read requests. Before completing the video, we'll cover Amazon Aurora's Custom Endpoint and what business problem Custom Endpoint solves. If you watch this video and the other module in this series without skipping any content, you will get a clear understanding of the Aurora concepts you need for your daily task and to pass the AWS Solution Architect Associate certification. Let's get started. Amazon Aurora is a proprietary technology from AWS. Unlike MySQL or PostgreSQL, Aurora is not open source. Amazon Aurora is fully managed database compatible with MySQL and PostgreSQL, which means your existing applications, drivers and tools will work exactly the same way as if you were connecting to a standard MySQL or PostgreSQL database. That makes migration and integration much easier with Amazon Aurora. Now, what makes Aurora so powerful is that it's cloud optimized. Aurora has been built specifically for the AWS cloud, and as a result, AWS claims Aurora delivers up to 5 times the performance of a MySQL running on RDS or on a standard MySQL database, and over 3 times the performance of PostgreSQL on RDS, and this is without changing your application code. All that improvement comes from Aurora's unique architecture. Another key benefit is storage autoscaling. With Aurora, you don't have to provision fixed storage ahead of time. Instead, storage grows automatically in 10 GB increments up to a maximum of 128 terabytes per database. This eliminates a lot of the operational headaches around storage planning and capacity limits. When it comes to replication and scalability, Aurora again stands out. You can create up to 15 replicas compared to just 5 replicas in standard RDS. Even better, the replication lag is typically under 10 milliseconds, which is much faster than traditional MySQL replications. This makes Aurora excellent for any read-heavy workloads where you need high throughput and low latency. High availability is also built into DNA of Aurora. Failover is essentially instantaneous. If the primary instance goes down, Aurora promotes a replica to a primary almost immediately. And you don't have to configure anything special for high availability because Amazon Aurora is natively designed for it. Now, one thing to keep in mind is the cost. Aurora is about 20% more expensive than RDS, but thanks to its performance, scalability and reduced maintenance, it often ends up being more cost efficient in real-world workloads. So to summarize, Aurora is proprietary, cloud optimized, highly scalable and highly available database, delivering enterprise-grade performance that justifies the higher cost. It's one of the AWS's strongest database offering, especially for mission-critical applications. Now let's review Amazon Aurora Database Cluster Architecture. An Aurora database cluster consists of one or more database instances and a cluster volume that manages the data for these database instances. Database compute layer and storage layer is loosely coupled and it can scale independently. The storage layer automatically maintains 6 copies of your data across 3 availability zones in a single AWS region. For a write operation, Aurora requires an acknowledgement from 4 out of 6 storage nodes and 3 out of 6 read quorum is required for read or repair operation. The 4 of 6 write quorum and 3 of 6 read or repair quorum allows Aurora to handle multiple types of failure without data loss or downtime. Since data is stored in 3 availability zones with 2 copies in each, the loss of one entire availability zone means 2 copies of your data are lost and the system continues to operate because it still has 4 out of 6 storage copies available, which satisfies the 4 of 6 write quorums and sustain loss of a single availability zone. Aurora also provides self-healing capability with peer-to-peer replication. Each Aurora database cluster has one primary database instance to support read and write operations and performs all of the data modifications to the cluster volume. And it can have up to 15 Aurora replicas in addition to the primary database instance. If a disk fails, Aurora heals it automatically. If a node fails, Aurora fails over to a replica. An automated failover for a master node is very fast and it can take less than 30 seconds. Since the replicas are spread across multiple availability zones, you have option to pick and choose which replica to be promoted as primary in case of failure, and you can assign failover priority. The compute layer is responsible for SQL, transactions and caching, whereas shared storage volume is responsible for logging and data storage. The storage layer is backed by Amazon S3 and Aurora continuously back up the data to a S3 bucket, and that is why this architecture ensures high durability, fault tolerance, cloud native capability and inbuilt resilience. Amazon Aurora automatically adjusts the number of Aurora replicas in a database cluster based on the workload. Unlike RDS, Amazon Aurora provides one reader endpoint for all the read replicas. So with Aurora, you will have only one reader endpoint and one writer endpoint. Aurora Auto Scaling is available for both Aurora MySQL and PostgreSQL engine. Aurora Auto Scaling enables your Aurora database cluster to handle sudden increase in connectivity or workload. When Aurora Auto Scaling adds a new Aurora replica, the new Aurora replica is the same database instance class as of one used by the primary instance. Now, if you are thinking how auto scaling works in Aurora, then this is the answer for you. Aurora Auto Scaling integrates seamlessly with Amazon CloudWatch, and you start by defining a scaling policy where you set as target metrics such as average CPU utilization or average database connections, and you can use this CloudWatch metrics. Please remember this metrics name, RDS reader average CPU utilization or RDS reader average database connections. You can also specify a minimum and maximum number of replicas for your cluster and the threshold value. When read traffic increases and your chosen CloudWatch metrics goes above your target threshold, then auto scaling policy is triggered and Aurora will then automatically provision or add new replicas to your cluster. And these new replicas will join the reader endpoint. Conversely, when traffic decreases and the metrics fail below your threshold, Aurora will automatically scale in by terminating the unneeded replicas. Aurora Auto Scaling only removes Aurora replica that it created, not the replicas that you create or add manually or using any infrastructure as code script. In terms of Aurora Read Replica Auto Scaling benefits, the first is cost efficient. You pay only for the capacity you need by scaling down during the low demand periods, and also seamless scalability. Aurora Auto Scaling maintains application responsiveness during sudden traffic spike by adding capacity automatically. And also it distributes read traffic and can failover more quickly by promoting a read replica in case a primary instance is failed or primary instance is not responding. Now let's review Amazon Aurora Custom Endpoint. While the default reader endpoint handles simple load balancing across all read replicas, however, in many applications, not all queries have the same priority. Let's assume you have an analytics workload running with your e-commerce web application. Then the resource-intensive analytics query could compete for resources with lightweight, high-volume transactional queries, which will potentially slow down the core application. That's when Amazon Aurora Custom Endpoint comes in. With Custom Endpoint, you can route connections to a specific user-defined subset of instances within your Aurora cluster. As shown in this diagram, you can create multiple custom endpoints for different purposes, which allows you to effectively segregate and manage different types of workload. The core of this feature is workload segregation, and let's understand the concept with our existing example. To prevent complex analytical queries slowing down your customer-facing transactions, you can create two custom endpoints. With Custom Endpoint for web application, you can route the web application simple read queries to one set of replicas, and then the heavy reporting queries to another set of replica or to a larger replica using the custom endpoint for BI. You can use the writer endpoint or cluster endpoint for your applications to perform write operations like insert, update, and deletes on the database. You can either create custom endpoints for read operation, write operation, or any, which gives you even more control over which connections are routed. You can also optimize performance by using different instance size for different custom endpoints, which will ensure resources are allocated efficiently. This concludes part 1 of Amazon Aurora Deep Dive. Amazon Aurora offers many features and capabilities. To make the video easier to understand, we broke the concepts into smaller videos. In our next video, we'll explore Amazon Aurora serverless capabilities and global database. We noticed that 80 to 85% of our viewers are participating in this bootcamp without subscribing to our channel. If you are one of them, please consider subscribing to our channel. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We'd love to hear from you. Thanks for learning with us at CloudExpert Solutions. You are now one step closer to crushing your exam. See you in the next module.